Hello everyone, and welcome to the NexusForum talks. My name is Tana Medakovic. I'm from F6S, a partner in this project. And today I will briefly introduce you to the NexusForum project and then leave the floor to our speakers today who will be talking more about the working groups that we have, as well as the working group that they were participating in, which is on topic of sustainability. So I hope you can all see my screen right now. Okay, great. When it comes to the NexusForum project, this is a project that has been taking off for 2.5 years. There were many things that we were doing, but our main aim is actually to provide this new vision of the different areas and directions that this project covers. More specifically, or let's say practically, we have been delivering a special, let's say, outlook on the cognitive computing continuum future. We were collecting data, structuring them in roadmaps, covering different domains, as well as creating international synergies such as those with Japan and South Korea. These are the working groups that we have formed during our work in the project. And as I mentioned, today we will be actually finding out a little bit more about the work done and some topics that emerged in the sustainability working group. So for that purpose, I'm very happy to introduce John Summers from RISE, or Research Institute of Sweden, as well as Damien Dalton from University College of Dublin. So, John, the floor is yours.
Thank you, Tanya. Yes, so that's great. Yeah, so we're just going to have a little bit of a conversation about a few things that have come up in our discussions around the sustainability aspect of the cloud continuum. And I guess there's a lot of topical issues around sustainability and data centers, digital infrastructure, and it's hit the news a lot. So, and the media sometimes gets it wrong, sometimes overemphasizes it. So we thought a good collaborator with myself, Damien from University College Dublin. We both come at it from a little bit different angles. I'm more of a thermal management guy. I think, Damien, you probably can say you're more coming from the workload side of, from what I know of your research and how we've interacted over the years. So, but let's just start off. We've got a couple of questions that we want to get through in this short period of time, and we have no more slides. We're just going to talk around these questions, but feel free to pop questions in the chat to direct us or disagree with us or agree with us, whatever you want to do. But anyway, so data centers are obviously huge. You know, now the topic is that these data centers, we're talking about gigafactories. We're talking about a gigawatt going into some of these largest data centers, these what they call frontier data centers. And of course, you know, this is causing pushback. I mean, Damien, you're from a country that has probably the highest percentage of their electrical grid going to data centers. Yeah. I mean, what do you think? What do you think we should do about this this data center transition? You know, this and how they can we actually get them to be, you know, proper prosumers within the energy network? I mean, what's your view on this? Yeah.
Yeah, just to give some context for for the answer is that currently about 22% of all the energy in the national grid goes to data centers, compared to I think at an average would be about 3 or 4% in European cities. You know, so we're way off. We're an outlier in regards how much energy goes into data centers, and it is causing a lot of public sort of outreach, there's the allegation that they're sort of not contributing many jobs and consuming vast amounts of energy, and they consume all the renewable energy. So they only, for instance, although they're 22% of the grid, they only produce about 2% of the carbon emissions because all the other consumers are using the fossil fuel content of the grid in consumption. But at the moment. the data centers really are more consumers than contributors. And in Ireland, we have the problem that if data centers were to be contributors to the grid, the grid hasn't got the capacity to absorb a lot of the surplus energy that the maybe the data centers can supply when required. And it's a sort of a complex issue. You need an intelligent grid. You need to have a whole the technology has to be there to support this interaction between data centers and the grid. And we're really about 5 to 10 years away from that. I don't know how it is in other countries, but I think largely with AI now, we have to really consider like what are we doing? How can we? With the EU has the Energy Efficiency Directive, and we have to take various metrics to be compliant with that directive. And one of them is performance. And there have been other metrics that we've been using before, like PUE, which is doesn't I mean it's a very rough metric, but when you want to see like what is being done and how it's being done, and I don't see certainly in Ireland, apart from periodic periods, data centers are going to be net sort of takers from the grid. Other countries, are doing more. For instance, in Ireland, we were not allowed to have nuclear energy. So the idea of having even like small nuclear reactors, which is some of the bigger data centers are considering in America, we cannot consider that. So there's a lot to be done, both in analyzing how we work the large data centers, particularly with AI, how we connect to the grid, how intelligent is the grid, and really for people to decide what sort of models they're going to use. Like, are you going to use a 7 billion parameter model, or is a 4 billion sufficient? So there's a lot of answers we have to, get before we really can consider our data centers going to be contributors or, as you say, producers of electricity for the grid.
Yeah, I think when I put in this question together, some of the things that have come up in the which will appear in the roadmap or has been mentioned in the roadmap. It's about the Energy Efficiency Directive again. Is that with the energy networks, I think also data centers are very efficient at converting electricity into heat, although it's an extremely low grade of heat. I mean, you brought up the topic of renewables. One interesting fact that stuck with me a lot is that globally, the ICT is ICT alone is contributing to 55% of the renewables. So that the consequence of renewable energy generation on the electrical grids, 55% of that is attributed to ICT. It's not necessarily the case that data centers in Dublin are consuming green electrons. So they're still using a fossil grid, but they have been a major push to the developments of renewable energy for our grids, for our networks. But on the topic of heat, I mean, obviously this is really the difficult one. We know the Energy Efficiency Directive is being consumed in different countries in different ways. I think Germany is definitely taking it on in its true value, in the sense that what is it? If you're over a megawatt in size in terms of power draw to your IT, a certain percentage of any new data center developments has to consider the recovery of heat. And you've got to demonstrate that it's technically or economically not feasible to do this. But in the Nordics, there's a lot of great examples of where data centers are interacting with the heat networks. It's just very difficult because we don't have the infrastructure for heat networks everywhere. So I guess the question is certain types of workload, and I guess we're sort of preempting something that we're going to talk about a little bit later on. Certain type of workloads should be done in different parts of the globe where the data center can interact with the energy networks. Do you think that is something we should be pushing? And I mean, I guess it requires a lot of joined up thinking to be able to do these kind of things. But I know in Ireland, I don't think much of the heat recovery is
we only
happening.
have one heat recovery from a data center in Dublin, and that's to sort of a local housing community. And it's very limited. It's really sort of a prototype. I mean, the trouble now is planning is a big issue. There's a lot of politics involved in it.
Absolutely, yeah.
Yeah, so it takes like
Mm.
it has. I mean, although the government has said that they're going to accelerate the planning process, it has been taking 10 years to get from sort of concept to sort of turning on the computers in a data center, and that's far too long. And there are too many agencies. Now, there's been a revision of the policy and the strategy to achieve greater resilience and more integration between all the various parties involved in data center computing. But I think we can take examples certainly from like Denmark and Sweden, how, because I mean, we're going to get really in excess of heat from the AI data centers of the future. There's just so much energy being generated there that we have to consider making productive use of the heat reuse rather than just pumping it out, or cooling it, whatever may be happening at the moment. So yeah, there's a bit of several milestones we have to achieve here. But I think what you've done in Scandinavia definitely is an example that we could follow here. But I said there is a big infrastructure deficit in Ireland. For instance, we could produce, to get illustrated, various data center companies like Google were invited to come into Ireland like 10, 15 years ago, even longer, on the basis that the government would put the infrastructure in. And the data centers came in thinking that was going to happen. But then there was only one offshore wind turbine system. It was one of the first in Europe off the coast of Dublin, North Dublin, in around the early, I think, 2002, 2003, but none were built since then. And we have capacity to generate 4 times more energy than we require if we were put wind turbines in the west of Ireland in the Atlantic. And with that, there's always an issue about, renewable energy. How do you, when the wind doesn't blow, what do you do? But there are battery storage systems which are very effective. Like they are in Ireland now, they're putting in acre-sized battery systems that can deliver like 2 megawatts for 2 hours. So those type of the developments are happening, but we need more of them. But it shows what can be done and how there can be a symbiotic relationship between data centers and the grid. So they're not just seen as the bad guys, the guys that suck at all the energy. They can actually provide a vital component in supplying energy when there isn't sufficient energy in the grid. But it does take the infrastructure and the foresight to do that.
Yeah, I mean, I think this is one of the biggest topics. I mean, definitely, for example, in the US with the larger data centers that have been trying to build, they're trying to get connections to an electrical grid, and they're told you've got to wait 10 to 12 years. Of course, they're going to miss the opportunity for what they want to do with that data center. So that's why they're now choosing on-site power generation. So and I think there was always, I do recall the Green Grid. It was Christian Bellardi, I think, that was talking about this back in 2015, who is actually one of the co-authors of the original paper on the power usage effectiveness metric. And he said, we should be putting data centers inside power stations, not so because they're so they require power, but they're also, can be, you've got a mixture of heats then, and you can actually do a lot of things with 3 different temperature, the outside temperature, the temperature from the data center, and the temperature of power generation.
But even John, I was talking last week to a wind turbine company here, and they're saying that they can produce energy, electrical energy with their wind turbines. It costs 6 cents. Then to transmit that at the moment costs 13 cents.
Yes, transmission is a real issue, isn't it?
So if you had the power plant beside it, you wouldn't. The transmission is like 100 yards maybe, but it shows you like there is, there has to be joined up thinking to all of this, looking at all the various moving parts of a data center, the grids, users, suppliers of energy, and really to take a holistic view of things, because that's the only way you can really achieve economically the goals and reduce the carbon footprint, and they're not competing.
Yeah, I mean, it's a shame that with the fact that both solar and wind are intermittent. I mean, the amount of infrastructure that needs to go into storing energy. This is a big issue from the point of view of material resource. Because battery storage are large systems. They require a lot of infrastructure, a lot of material. One of the things that I've noticed that it could be considered here is if you had unmoored wind turbines and you put the actual data center in the base of the unmoored wind turbine, and then use the, say, like a network like Starlink to connect to it, move it around, get the maximum energy out of the climate, because that's
Yeah.
wind is very much a climate. It's a solar driven activity, isn't
Mhm.
it? And so
Mhm.
I think we could have the whole session on this particular topic at the moment, because energy is probably the biggest issue. I
Yeah.
mean, yeah.
And
So yeah,
so the idea is saying of this sort of the CPU computing following the wind. It reminds me of a project which we put together some years ago. Unfortunately, it wasn't successful, and it's called the sunflower. And you know the way sunflowers turn their heads towards the sun.
sun. Yeah,
Yeah, so
yeah,
you had the same idea for data centers, that the data would follow for computing would follow where the wind was blowing, and I think that really has a lot of a lot of benefits, a lot of good things going for it. I don't know where it is in terms of reality, but I can see how we do have to have imaginative projects like that if we are going to reach our 2030, 2050 goals, underneath
yeah.
under the
Because an industry, yeah, yeah, an industry that has been focusing on trying to be net zero. Now
yeah.
is building on-site power generation in certain parts of the globe, which are fossil
Mm.
fuel based, is not going to manage that. Let's move on to the next question, because I think this was one
Oh,
interesting
right.
one, but we did you mentioned power usage effectiveness, the PUE, this metric that actually some cynical people say it was a paper that was produced back in 2006 at a conference in September 2006, before the Green Grid actually took it up. And it was the two authors were from a company that manufactures IT equipment at the time. So it was a great metric to say, don't look at the IT, look at the infrastructure around the IT, because
Mhm.
PUE, it doesn't say anything about, it's a ratio of the amount of energy that's consumed.
Sure.
Now it's a ratio of amount of energy that's consumed by the whole data center divided by the amount of energy that goes into your IT. But you don't know what the IT is doing. You don't know how big that one is in the denominator. But I mean, what do we do now that we're in this? What are the metrics that we should be using to try and figure out what we mean by an energy efficient data center, or
Yeah,
a data center that's
it,
efficient? Yeah,
it really is a great question. Just to follow on from what you were saying there, some people say cynically would say that PUE refers to a pretty useless entity because it doesn't give you it's an acronym because it doesn't give you a lot of detail what's happening in your computing assets. That you could have everything, all the energy going to your computers, but if they're doing nothing or idling or wasting or not being productive, it doesn't really give you any indication of that. But like what we're in the School of Computer Science here now, we have 85 servers, very small. But what we're going to do is look at how productive are the servers, and this is something that you have to do under the Energy Efficiency Directive. I think it's under so Annex 7 or something like that. It gives you about 20 different metrics that you have
yeah,
to.
yeah,
Now, some of these are defined under the ISO, 5600, but some are a bit nebulous. They refer to computer efficiency or productivity. And I think to have a general metric for productivity is going to be very difficult. It's like asking how long is a piece of string. So I said, like in our School of Computer Science here, what we're doing is we're introducing our system that we've designed here that can analyze the energy consumption not just on the server, but also in terms of the applications. And so what you're looking at then is looking at you can determine what is the consumption of an application and then look at what activity that application did. Like what was it appropriate? It might be like searching a database or it might be answering queries. And so you are able to look at the performance of that in terms of the basic actions that it's doing, taking into account the energy it's consuming. So you could look at a server this year and see how much it costs to, say, access a database a million times and then how much energy with a new server next year it costs to access an updated database. So you have metrics that are they have to be meaningful and comprehensible, because you don't want something that's too technical. You want something that people can readily understand and is appropriate to their level in an organization. So what we're using are what we would say are user-defined metrics rather than ISO metrics that are standardized, because I don't think you can get a standard for it. And the way I'd say it is that it's using an analogy. When James Watt wanted to show the efficiency of his engine, to the hard-nosed. Well, this is from you're from the north of England, I think, John. It's the hard-nosed business people of Yorkshire.
Yeah.
He was able to change it into a narrative, how so that the industrialists could understand his engine in terms of horsepower. How many horses would you need to give the same amount of power as his engine, and that made it comprehensible. So you could say this. He was able to say this engine is 10 horsepower. So in your mind, you can think the industrialist can think, well, I need 10 horses, and I need 10 stables, and I need 10. I need to have hay for 10 horses to do this job. So we need to do something similar to that. Have user-defined metrics so that we can understand how efficient one system is compared to another. And that isn't standardized. And I don't think you can standardize it, but you want to have something that gives a handle and which is pretty easy, and comprehensible to the users of the metric.
Relatable, yes. I mean, I guess that's a really interesting thing. I was putting a talk together, and I went back to horsepower, and
Oh,
most
right.
people talk about most people are interested in their the horsepower rating of their vehicles. It's kind of still a
Mm.
metric that's still used
Yeah, sure.
today, and some of the high end. So we're now putting in racks for AI that have the same amount, a single rack that has the same amount of horsepower as a high end Mercedes,
Wow. Yeah.
and then you put 6,000 of these into a data center,
Mm.
So and they're on all the time. I mean, horsepower, it's a maximum, it's a peak
Yeah.
peak amount of power, but these things are running 24/7 at
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 max
peak
power.
power. Yeah, so it really is a difficult thing because as you rightly say, it depends on the application. And now when it's related to the energy that's consumed by the IT, it doesn't really tell you anything about the productivity of that. And
Mm.
one of the things I like to do to be a bit provocative in this area is to try and relate things to the incandescent light bulb. Now, the incandescent light bulb was a great invention, but it was so inefficient because it was only 5% efficient. So
Mm.
5% of the energy that went into it actually came out as light because it's a light bulb. That's what you want. If you use the same metric, if you measure the energy value of all the data that's coming out of your IT systems, you can do that
Mm.
using basic principles of physics. The
Mm.
actual efficiency, get this, not 5%, it's 0.003% efficient.
Wow.
So
It's
99.97% of the energy is being converted to heat. So we have a computing process that is not fit for purpose. And one of the things that this is where I'm getting excited a little bit here, but the likes of some of the company, a company that shall remain nameless here is going to produce a microprocessor that's going to be named after a very famous physicist called Richard Feynman, the Feynman.
all right.
Yeah. Now, if you know anything about Feynman in the 80s, the last 10 years of his life, he worked on the computing process. And he said, engineers should be ashamed of themselves at how inefficient the process is that we're
Mm.
using today. That microprocessor of the future that's going to be called the Feynman,
Yeah.
yeah, and we
It's a shameful use of his name.
yes, shouldn't happen, should it? We need to
Yeah.
have
Yeah.
pushback on that. But anyway, I guess it doesn't really solve the problem. We need a metric, and we've always got caught up on metrics here, and of course the PUE is in the Energy Efficiency Directive. It's something that and there is a
Mm.
when the building of data centers in different geographical locations has been mandated against what's called the design PUE. So
Mm.
when they design the data center with all the infrastructure, they are targeting a PUE that has to be less than 1.2 usually.
Mm.
Now, if you know anything about refrigeration systems, that you do need to engage sometimes, when the temperature is, over 30 degrees outside, you need to use refrigeration. And that will always push you up over a
1.2.
value that's
Mm.
greater than 1.2. But of course,
Mm.
it's an annualized value. So in the winter, you might not use
Yeah.
refrigeration.
Yeah.
But anyway, it's a complicated topic,
Yeah.
something that we're not going to resolve here. I think it's meant some of these metrics are mentioned in the roadmap, and something that
Well, did you
really need.
say, I think, John, just on that, is the
Yeah,
AI and they're looking at, the air cooling, I think, are beyond about 20 kilowatts on a rack is not going to be in the running. That the direct chip cooling is something that is being explored now, and that
Yeah.
will bring down the PUE quite considerably. I think particularly the
Well,
two phase.
yeah, I mean, what it does do is it makes it more climate agnostic. The problem we have at the
Mm,
moment with air cooling is in the north of Sweden, you've got cold air all the time, so it's easy to reject the heat. In the south of Spain, it's not so easy. But if you
mm,
raise temperatures when you go to liquid cooling, then there isn't so much difference between the south of Spain and the north of Sweden in a
yeah.
sense, because you can reject, because you're operating at higher temperatures,
Mm,
you can reject the heat. Although, and that's where, obviously NVIDIA did say with their next generation Rubin, you can run at 45 degrees centigrade. And then the HVAC industry panicked because they said, oh, well, that means, if you install NVIDIA, you'll never need a chiller again, and so
yeah.
we will never be able to sell a chiller to a data center. But that's not the case. It's actually much more complicated than that.
Yeah.
Um, shall we move on to our next
Sure.
question? So, so and it is a little bit about cooling. So it actually links to the question that sustainable cooling and liquid cooling. You know me, you've known me for a long time. I've been working in liquid cooling from
Sure.
2010. And liquid cooling is a very old concept. I have a paper from the 1960s which has a phrase in it: the use of liquids to cool microelectronics is apt to frighten the electrical engineer.
Mm.
So mixing liquids with electronics does seem to be
What was
counterintuitive.
water? What they had in mind at that stage, was it, rather than giant
Probably,
liquids?
probably, yes. Yeah, going to short circuit the.
Yeah.
Well, remember when you drop your phone of old before it became water resistant, but the old phones, if you dropped it in
It's
the
short, yeah,
if you
short
dropped it
out. Yeah.
down the toilet or you dropped it in the bath or something, it's dead, isn't it? You'll never
Sure.
survive. But so I think raising temperatures is one of the biggest issues in this industry. But as we are on this sort of cusp of compressing, and putting more and more transistors on microprocessors. So it's going like there's a 30% increase in the density of transistor per cycle per
Mm,
year increase, and of course those transistors are getting less dissipative in a little bit, but they're
mm.
not getting 30% less
Yeah,
dissipative.
yeah.
So the TDP, the thermal design power of these things, is going up. And as a consequence of that, the temperatures are going down. So
Mm,
even if you go to liquid cooling, you still can't run at temperatures you thought you could run at because
mm,
you've invested in liquid cooling. So as we densify, computing for particular workloads, this is where we get ourselves in a little bit of trouble because dense IT is not required for everything. Banking
mm,
services, cloud operations, that can be done on much sparser IT. You can spread it out.
mm,
But when you have operations which require very, very short distances distances between compute elements, like in
mm,
high performance computing,
mm.
like in AI training workloads now, we need densification. But I think really, at the end of the day, yes, let's build that. But I mean,
Mm.
what we're seeing, I think, is that you need AI enabled workload right next to standard workload now, because banking, for example,
Yeah.
has a big investment in AI, fraud detection, all that kind of thing. So they
Mm,
need dense equipment next to sparse equipment,
mm.
which is interacting with their
That makes it very
customers.
difficult from an
Yeah.
infrastructure point of view, really, isn't it? Because you're sort of looking at these, hugely dense systems, and they're being phased in. And how do you phase them in? Because you need a lot of retrofitting if you're going to start using different types of cooling in the future. If you've been using air cooling, now you're going to go over to liquid cooling and immersive cooling. Then you're going to, on chip cooling. How do you manage that in a company? You have to get your sort of, horoscope, get the, glass ball out and try and see the future.
Yes.
Because it's
Yes.
going to cost millions to put the infrastructure in, and you want to get it right.
Yeah, absolutely. I mean, actually, it's probably not millions anymore. It's billions of
Yeah,
dollars that they're
sure, yeah,
spending on these things, aren't they?
yeah.
Particularly for the large infrastructure.
Mm,
So, I mean, sustainable cooling really is about, in my view, uh, is I guess the word cooling with with infrastructure is a kind of an empty word. What you want to do is talk about heat recovery, perhaps going back to the beginning of energy interaction. So that and there's a company in Ireland that has that I interacted with that did direct to chip cooling that used the phrase that data centers borrow the energy. So they just,
Right.
okay, yeah, they're transforming it, but they borrow the energy and pass it on
Out.
to something else that can make use of that energy. But I think, that's not easy to do when you've got geographies that are very different. And also you've got seasons, We talked about
Yeah.
heat recovery. Yeah, sorry. I mean, I was just going to say in the Nordics, it's also tricky. We could in the depths of winter, it's good. You can a data center can connect to a district heating network, and the heat can be used. But sometimes in the middle of summer, the heat network says, no, we don't want your heat.
Mm.
You've got to deal with it yourself. And so now you're in this sort of difficult situation of, well, what infrastructure do I put into my data center in order to be able to connect to the network? But in the summer, when the district heating network doesn't require my heat,
Where does the heat go?
Yeah, what do I do with the heat? Yeah, so
Yeah, because I think it was a recent survey. I think it was Carnegie Mellon in the States recently said that the large AI data centers are increasing the ambient temperature within a 6 kilometer radius by 2 degrees. I mean,
yes, yeah,
that's
I
really
saw
quite
that.
a
Yeah,
site. I
yeah.
mean, that's making it really hot for the inhabitants, residents of data centers.
Well, I think if you think about it, it's that gigawatt data, that 5 gigawatt data center that is being produced by Meta, I think, is
Mm,
half the size of of Manhattan,
incredible.
and yet it's consuming a lot more energy than
Yeah,
Manhattan. So it's the urban heat island of
yeah.
cities is a well-known fact. Now you're going to exacerbate that heat island with these large data center
Yeah, the data
infrastructure.
centers.
Yeah.
Yeah. Do
So
you think the data centers have a bit of responsibility to be a bit more transparent, and in their disclosures? For instance, like in Ireland, we've had two reporting deadlines on the energy efficient direction, and both have been missed. Now, I think the government is as much to blame about this as the data centers. But I mean, they do. I mean, when we had COVID, we were grateful to the data centers providing the connectivity
yeah,
communication for. But at the same time, they are contributing significantly to a lot of environmental issues. And I mean, and when you look at the priority that data centers are putting on sustainability, it's usually about number three in the list. Normally it's resilience and capacity, and then the
yeah.
third item is sustainability. So it wouldn't should it really be pushed up to the top, or or is it a case that the government has to really make that move, has to use a bit more of a stick, or is the public responsible, that they require resources from data centers that are, environmentally, aware and doing something about it? They're sort of conscientious environmentalists as much as producing the cloud
Well,
facilities.
this was a topic that came up in the working group, wasn't it, really, about how
Yeah.
because at the end of the day, the data center doesn't really create the problem. It's the users of the
Mm.
infrastructure that create the problem. But how do you inform your users about what they're using and how they're
Yeah.
using it? And I think there's a lot of topics now around digital sobriety and
Mm.
sufficiency and these aspects, which are really more of a human interaction with the
Sure.
infrastructure.
Yeah.
And I think most people don't know what their actual environmental footprint is from the digital services that they
Mm.
use.
Mm.
I mean, everybody now is dropping search engines and going straight for AI to get
Yeah.
answers, and of course we know that AI is so much more energy intensive or requires a lot more resource than a search engine. So,
Yeah,
but
about 10 times. Like you can put a
yeah,
search in, rather than
yeah,
asking, Gemini something, what's the capital of Spain or something like
yeah,
that.
and yeah, it's got to interpret what you're asking it, and then it's got to figure out the answer, isn't it, from its.
Yeah, yeah.
But I mean, it's yeah, and I think I don't know how we deal with that. I mean, obviously, and I think you're right. Governments and governments always get themselves into a bit of a pickle over
Pickle.
these things, and the energy efficiency directive is, yes, it's the member states that have to report. So they have to have, member states have to have the infrastructure in place. And I don't think many of the countries in the EU have really got that
Yeah, they
together.
haven't got the handle on it really.
Only Germany, I think, is the only country at the moment that has
Yeah.
managed to, as far as I'm aware, but it's I could be wrong there. Yeah. I haven't tracked it so carefully. I'm aware of a time,
Yeah, sure.
I
Yeah, it's
mean,
really interesting. You get carried away.
yeah, well, we both do, don't we? I think we're maybe a topic. Maybe we should take this as the last question, Tanya, as it's getting late. But maybe this last topic, which is close to more Damien's heart, I think. If you go to the next slide, if you can, because I know this is something where you place your workload and how, and should it be aware of the infrastructure that it's running on. I know that's
Yeah.
something you've been looking at. I mean, what do you
Yeah,
think?
it's not just AI work, it's just workloads in general. And so it really comes
Yeah,
back to the technology that we've developed in School of Computer Science. It's called Papillon. And what that does is actually it's able we're able to monitor the energy consumption of the physical server, but also the applications that are happening inside it. So you may have one physical server and you may have like two VMs on it and 10 applications, and we can give you analysis of all those things. But what it does is that knowing that, then you can look at those applications. Say, do they need to run now, or could they run at 2 in the morning when when there isn't the same carbon intensity in the grid as there is now? It gives you the decision process. It gives you the decision capability to be more in. You don't have to even use AI. You can just look at it on a spreadsheet and say,
yeah,
why are these processes running, at 12 o'clock? These are large physics calculations that can be done at 2 o'clock in the morning. So from a simple point of view, with that level of analysis, you can do that, that simple, a management of the servers by just shifting things around, maybe even manually doing it without doing it intelligently. But does it scale? Yeah, it does scale, but I think what we can do academically and what we can do in a commercial environment are completely different things. I think when it comes to commercial operations, everyone wants to have their applications running in a cloud that are immediately responsive and there's no sort of shifting them around. It's very hard if you're running a data center to start dictating to your customers the scheduling and how you're going to manage them. They basically want to run their services at any time during the day, regardless of carbon intensity or demands on it.
yeah. I think
Um,
that's yeah. I
so
mean,
yeah,
I do remember reading an article. I mean, this is quite a few years ago. I think Google had this follow the moon policy because they had the infrastructure around the globe, so they
mm,
would run heavier workloads when it was at nighttime,
mm,
and it was easier to get rid of the heat because it were cooler
mm,
outside temperatures. So they took advantage of that. So I guess that's not carbon aware, but that's sort of climate aware, if you know,
yeah, yeah,
or ambient temperature aware.
mm,
So I think a lot of this has been talked about, and actually the EU has funded a lot of research on this. And over the years, I've seen lots of different projects trying to get not just AI workloads, as you say, standard workloads, or even routing traffic, through
yeah,
a route that is actually much lower carbon intensity. So
mm,
your end-to-end communication, because obviously it's not just data centers, it's the
the
network,
network.
the telecommunications, and there are hops, and the hops
Mm,
could follow a route that has a low carbon intensity. So there's
mm,
lots of clever things that we can do like that. But you're right. We can do these things in the lab, and you and I, we do stuff in the lab. But we always get the question when you interact with the commercial facing side of this. Well, does it scale? And
mm.
it's not easy to test that unless
Yeah.
you actually deploy it. Yeah.
Yeah, until you get large systems, it's very hard to answer that question because
Mm.
say, well, lab experiments always work, but
Mm.
practical applications don't, and no one wants to take the gamble of
Yeah.
of of their delivery of whatever the services are being diminished or degraded in some way, and that's the hard one to get over. And I think it comes down to really where in the hierarchy, in the business hierarchy of large data centers, do you have like what we now call like a chief sustainability officer, a CSO? Because it has to really come down from the top of an organization to say we need to explore, we need to implement some of these new technologies, these new concepts into our operations to see, are they working or how can they work? And until that happens, the technology, remains in the lab, but you need to have a strong push down from from the senior management. To give you an example of how I was naive several years ago, I won't say who the company is or the organization is, but I went to a data center and said to them we had a technology that could, look at what they're doing, identify energy saving actions. And after about 2 or 3 hours, a guy agreed that we could save 300,000 in his electricity bill. And then I thought, oh, that's good. He's going to, give us an order. And he said, well, I'm not going to do it because my responsibility is just to keep the data center running 24 hours a day, 365 days a year. I don't get paid for efficiencies. And he said, if I take your system, it could cause me a headache. And why should it get a headache if I'm not going to benefit from from the process? So basically, it went nowhere. And I said to
Yeah.
him, thanks for being so honest. So, obviously the conversation is not going anywhere after this, but that attitude has to change. There has to be some incentive for companies to be seen, and maybe by having so I don't know, maybe a sort of a star standard for data centers that is authentic, that it has a number of metrics that it looks at in terms of the operation of the company, and you have a 5-star or 4-star data center, and then it's up to public procurement and customers of those of data centers to decide where do they want to put their money, where do they want to have their services, resident, and go for the ones that are making those changes. And that's a big ask, but we have to do something along that. Otherwise, we're not going to get the technologies, the new emerging technology, which can solve the problems. I mean, I think we can solve a lot of the problems if we just are adventurous enough and bold enough to employ them.
Yeah, and I mean that's the case with even with energy recovery from data centers.
Yeah.
It's not a technical issue. It's a more of a planning issue
Mm.
or a commercial issue from the point of view of trying to get things joined up,
Yeah.
and maybe it needs to be incentivized by governments. I mean,
Yeah,
yeah,
definitely. Yeah.
I mean, I know it was interesting. I don't know whether it's the case anymore, but Finland were incentivizing tax breaks for companies that data centers that deployed there and did heat recovery. So if
Mm.
you didn't do heat recovery, you wouldn't get the tax break. And I know obviously, Ireland has attracted a lot of infrastructure to
Mm.
because of taxation, and so
Taxes. Yeah.
yeah, so you can make these things work in some respects, but I mean, I guess this is where you place your workload, and it goes back to should we be moving workloads to
Mm.
particularly certain types of workload. We know if it's batch, in the form of
Yeah,
if
that's
it's not
ideal for it.
transactional, we just move it somewhere where
Yeah.
to Iceland. I mean, Iceland said run on our grid, but actually
Yeah,
I
and
would
just transfer it across.
I would contend that geothermal is probably not as environmentally friendly as hydroelectric because
Mm.
or even wind, because you're extracting heat out of the ground, and that's the anthropogenic heat flux that we're creating from extracting heat from other sources and putting it into the environment is not actually good either, But then they
Mm.
say, but now geothermal is a renewable source of energy. But
John, Damien, I would also like to use the chance, to see if there are any questions from the participants.
Mm.
So far, I
yeah,
don't see
thanks. Yeah,
anything in chat, but also feel free to raise your hand to jump in. I think this is a very, very interesting and I would say inspiring discussion as well as educational. A lot
Mm.
to unpack. Okay, so I don't see any hands raised or any questions in the chat. As I mentioned, I think you have covered a great deal of questions today. Unfortunately, this is just the scratching of the surface, right?
Mm.
So in that case, I would also like to let our participants know that the roadmap will be public soon. So you would also be able to see insights not only from John and Damien, but also from other experts in this regard. And also, I would like to use this opportunity to invite you for our final event. So after having organized three summits in Brussels, one in South Korea and one in Japan, this time we are taking it online. And we hope that you will be joining us. On the other hand, I would like to quickly get back to John and Damien and ask if you have any final remarks or comments. Again, this is a very non-exhaustive topic and a lot of practicalities to cover. So yeah, just getting back to you quickly for some final remarks.
Yeah, no, I was going to say to the audience that tunes in and listens to this later on, feel free to reach out to Damien or myself, about any of the points that we've raised. We're happy to answer that. But also, to engage with obviously the final stages of this NexusForum event. But and to thank Damien really, because Damien, agreed to jump on this chat with myself. And so, and it's been a great interaction. There's a lot more we could cover, Damien. But
sure. But thank you very much, John, for the invitation, to you, Tanya, for setting it up. As ever, it's always enjoyable talking to you, John. So
oh,
it was an open door when you gave the invitation, because you're always at the cutting edge of what's happening. And talking to you, I feel I can get some finger on the pulse of what's happening in the data center world. And so it was a pleasure. And if anyone has any questions, by all means, I would be glad to answer them. But thanks to Tanya and John for the invitation.
Well, thanks for joining. Yeah,
Thank you.
Thanks for setting this up, Tanya. Yeah.
Thank you very much, both. So the recording will also be available next week on our social media. Also, in order to register for the final event, you can find all the links there. So make sure to follow us. And again, thank you for joining today. Have a good day ahead.